Welcome back, Physics 30. This is the second video in the FM1.6 graphical analysis of linear motion section. So we looked at position time graphs, right? We looked at D versus T graphs. If it's a straight line, if we figure out the slope, it's just simply referred to as velocity. If it's the slope of a line joining 2 points on a non-straight line, a curvy line, we refer to that as average velocity. And if we're figuring out the slope of a point by drawing a tangent line and figuring out that slope, it is referred to as instantaneous velocity. So now we'll look at something similar, except this time a VT graph, a velocity time graph, and look at what happens when we figure out the slope of that. Of course, the slope of that is acceleration. So I just have one graph here. We're going to look at these three areas, so the straight line section, the curvy section, and then add an instant. So if we're looking at acceleration between 0 and 1.5, so that is a straight line section of the graph here. So we have 0, 0, and then 1.5, comma 4. So that's going to be my V2 part. And over here would be my T1 V1 part. So I just simply refer to that as acceleration because the slope in any part of that line will give me the same value. So acceleration is equal to change in V over change in T. In our case, we're going to do V2 minus V1 over T2 minus T1. So 4 minus 0 over 1.5 minus 0. Oops, 1.5 minus 0. So that's going to give us plus 2.7 meters per second squared. So that's just simply referred to as acceleration because no matter what 2 points I pick there, if I figure out the slope between those 2 points, I will get 2.7 meters per second squared. Now if I look at an area that isn't straight, so from 1.5 to 6, so now I'm using this as a T1 V1 point. I'm going from 1.5 all the way to 6, which is over here. And if I look at that point, that's approximately, so that's going to be 6.0, and it's just shy of 7, so I could say 6.9. So that's T2 V2. So figuring out, and again, yeah, it's going to make a difference where I pick my 2 points here. So this is on average, the slope of this line really is what I'm taking. So figure out the slope of a line joining 2 points, and I'd have to report that as on average the velocity is such and such. So acceleration equals change in V over change in T. So V2 minus V1 over T2 minus T1. So my V2 is 6.9 and my V1 here, yes, because I changed it, is 4. So 6.9 minus 4 all over 6 minus 1.5. 6 minus 1.5. So if I do that, figure it out, I do get a small positive number plus 0.64 meters per second. And then velocity at a particular point in time, so looking at your speedometer right at that point in time at 5 seconds. So 5 seconds is right here. So again, we just simply can't take a point divided by a point because slope implies that we have 2 points on that line. Just like before, if I pick kind of 2 areas equidistant from that point, so maybe here and here, I'll get my ruler and join up those 2 points. So you can see what my ruler is doing. This is approximately the slope in that area. And then just move it so I just see that point and that point only. And then I can draw my tangent line. Draw it nice and big because we're going to be looking for 2 points on there. So again, you'll be slightly different than mine. I see this point right here, which is going to be easy to read. So it's 6.25 and that's 7.25. So that's going to be my T2 V2 point for my tangent line calculation. And keep looking here, keep looking. Right here, there's a good point right there. It's where two lines meet. So that's going to be 2.75, comma, 4.25. So that's going to be my T1, V1 point. Okay, so finding points that you can easily read, that's the key for this last part. So the calculation is similar though, it's just how we get those 2 points that changes. So V2 minus V1 over T2 minus T1. So my V2 is 7.25 and 4.25. So 7.25, 4.25. And then my T2, 6.25 and 2.75. 6.25. And what was that again? 2.75. All right. So figuring that out, let's see there. So on top, I'm going to get 3. And then on the bottom, 6.25 minus 2.75, what does that give us? That gives about 3.5. So 3 divided by 3.5, that's going to give us approximately plus 0.86 meters per second squared. All right. So there we have it, ladies and gentlemen. Position versus time graphs. The slope gives us velocity, or average velocity, or instantaneous velocity. And then when we have a velocity versus time graph, slope gives us acceleration, or average acceleration, or instantaneous acceleration, depending upon which one we're looking for. So if we look at the assignment, I think the first page is relatively straightforward. It's very similar to what we did. Page 2, I think it's decent as well, very similar to the questions that we looked at. And then the last one, I threw one of my kind of real life scenarios when I used to own a manual Saturn, looking at figuring out, here's a graph that represents my speed as I'm changing gears. So you can see that's the scenario that happens. Determine the car's average acceleration. So it's a velocity time graph. So whenever I figure out a slope, that's going to give me acceleration. So the the flat spots represent the shifting of gears. So if I'm looking at what's the acceleration in second gear, we'll pick this area right here approximately. So from here, let's see if I can get a different color. So from here to here. So you kind of think of it as joining up those 2 points. And then as best you can, it's not the best graph, but you kind of have to infer what's going on here in terms of point, like what's that? Is that 12 or 13? You figure it out. And again, when you look at the answer key, look at, are you in the right ballpark? You don't have to get the exact same answer, but are you in the right ballpark? All right, so you should be able to finish that, and we'll see you again.